we're going to look at Newton's third and final law of motion. So what is Newton's third law of motion? Well, it states that for every action there is an equal and opposite reaction. Another way to think about it is that forces always act in equal and opposite pairs. Really important to remember, and this is going to come up later, that we're always talking about two objects in this case. So, for example, if you're sitting in a chair right now, you are exerting a force down on the chair, and the chair is exerting a force back up on you. Those forces are both equal in size, so the same number of newtons, and they're opposite in direction. So we can look at that. I have a little diagram here of a guy sitting in a chair. So again, as you sit down on the chair, you exert a force down on the chair. That chair is exerting a force back up on you. There's lots of other examples in this picture. We can have the feet pushing down on the floor, floor pushing back up on the feet. Also, the chair is pushing on the floor, and the floor is pushing back up on the chair. The cushion on the chair, chair on the cushion, etc. So let's look at some other common examples and look at those two forces in a little more detail. So generally when we talk about Newton's third law, we refer to an action force and a reaction force. Sometimes it's hard to figure out which one's the action and which one's the reaction. So generally the action force is the force exerted by the object that is in action. So again, if I go back to the chair, when I sit on the chair, I'm exerting a force on the chair, and the reaction of the chair is to push back up on me. The reaction force is the opposite of the action force. So whatever the action force is, the reaction will be opposite of it. So here, if we said the ball was in action, the ball is coming at the bat that it exerts a force on the bat then reacts to exert a force back on the ball. Equal and opposite. Same size of force, different directions. Here are some common examples that we see. A rocket launching is a very common example of Newton's third law. It's important to remember that the rocket takes off not because the gases are pushing on the ground. A lot of people say that the gases are actually pushing on the rocket. So when they light the engines, those gases are rapidly expanding, right, and pushing on that chamber inside the rocket. It pushes the rocket in one direction, and then the reaction force is for the gases to move in the opposite direction. And they create an opening so that those gases have somewhere to escape, otherwise they would blow up the rocket. The exact same thing is happening in a gun. So when you fire the gun, the rapidly expanding gases push on the bullet, and then it pushes back on the gun. That's also why you feel the kick of a gun when you shoot it. Lots of football action going on right now. So here we have the dolphin here is going to exert a force, an action force on the raven. The raven's body exerts a reaction force back on the dolphin. Swimming, if you're swimming, you're moving through the water, your body is exerting a force on the water, and the water is exerting an equal and opposite force back on you. So now we've got to put a couple of the laws together. So if all forces are equal and opposite, how do we actually move things? So if here we've got this guy and he's pushing on the car, according to Newton's third law, he is exerting a force on the car, and the car is exerting an equal and opposite force on him. So he shouldn't be able to move the object in that case, right? If all forces are equal and opposite, we would never have an unbalanced force. But we have to remember the difference between Newton's first law and Newton's third law. In Newton's third law, as I said in the beginning of these notes, you are always talking about two different objects. Person, car. Chair, person. Rocket, gases. So two different objects. In Newton's first law, which describes the motion and what causes things to move in a different direction and different speed, you're talking about one object. So let's look at this car example here. If I was to calculate the net force on this car, right, I could say, okay, we've got gravity pulling down on it, we've got the ground pushing back up on it, maybe some air resistance acting this way, and then we've got the guy's force here. If I was to assign some numbers to it, let's say I said 50 newtons here and 100 newtons here, we subtracted those two numbers, I would have a net force of 50 newtons acting in this direction. Therefore, the object would move and he'd be able to push the car out of the way. So, really important to remember that forces only cancel each other out if they're acting on the same object. Newton's third law always talks about two different objects. So that's the end of the Newton's laws. Make sure you have all of the vocabulary and examples written down, and move on to the practice.